Innovative construction and maintenance practices are an important part of repairing and preserving our nation's bridges. The Texas Department of Transportation, with help from the University of Texas Center for Transportation Research, is implementing more accurate estimates of shear capacity of post-tensioned spliced girders, a cost-effective and durable technology for bridges of intermediate to long span. These improved estimates cover both the cases where the ducts are not filled with grout at the construction stage, as well as the final stage after grouting. In addition, the implementation provides full design equations for both cases that will be adopted in national practice, an area of Texas leadership.
Commonly, prestressed concrete bridges have a limitation of about 150 or 160 foot span length, and that is defined by the limitations that we have in transporting these precast girders.
TxDOT over the last few years has been advancing the use of what are called precast, prestress, and post-tensioned splice girder bridges that use precast concrete. These structures enable what is usually the lowest cost bridge superstructure material to span longer than their typical precast prestressed beam cases.
We're giving the concrete industry a chance to compete with the steel industry to bid on longer span bridges to where the taxpayers can have the benefit from the competing bids to reduce the bridge cost down.
These beams typically have a longitudinal hole, if you will, that is cast into the girders, and it's used either a plastic or metal duct, which is typically about 4 inches in diameter.
And running high-strength steel strands through those ducts and stressing those strands in the field to clamp these concrete pieces together, after which commonly we grout them in the state of Texas.
What was important with this research is that we needed data on both grouted ducts and ungrouted ducts, where basically the post-tensioning strands are either have the addition of grout for their protection, but also the structural behavior before that grout is added. And so this research looked at the shear behavior of these beams to ensure the safety and service performance of these particular structures.
During the construction, there are stages in which the ducts are not grouted, and during those stages, the widths of the webs are significantly reduced for the fact that we don't have grout in place. So what is the shear strength of the web of a pre-stressed concrete girder with an opening inside is question number one. And two, a new to the United States technology came about, and that is having to fill these ducts with some wax filler or flexible fillers to where in the future, if there is a need to increase the post-tensioning force because of increasing demands in traffic, increasing loads, and the like, it is possible to remove those strands, rethread them, a greater number of strands or larger strands, and increase the post-tensioning force.
This technology allows us to increase the spans. It also gives us confidence in the shear behavior at both the construction stage and the final in-service stage.
For more information and to find the publications for this project, please visit the TxDOT Research Library at the link shown below.